Okay, ladies and gentlemen, a few announcements before we get started today. Just so you know, there is no class on Friday, July the 3rd. That is going to be a university holiday, the day that we observe 4th of July here at K-State. So there will be no lecture required, and there will be no homework on that day. So there's no homework today. So you've basically had the last homework assignment for the exam, which is next Monday, July 6th at 7 p.m. Just run just exactly the same as our previous exam has been run. So that's going to be expected that we will do everything the same way. I am going to run the review that morning a little differently. I'm going to do some problems in that review in the morning. I'm going to post those. Basically, my Friday lecture, Monday lecture is going to be the same. I'll post it on Friday. It'll be there for you to watch over the weekend, where I'm going to solve a few problems for you to look at, some closed system problems and some open system problems. To be truthful, you haven't practiced a lot in your homework. We've had a good number of problems, but not enough to get you ready for all of the varieties of problems that you could see. I mean, there's literally thousands of problems I could assign you for the exam on Monday. But just know there's going to be 4 problems. 2 of them are going to be closed system, and 2 of them are going to be open system. And then in those closed system problems, you're going to have to look and see if it's an ideal gas or something like ammonia, propane, R134A, R22, or water, and how you will handle those differently. If it's an ideal gas, I'll tell you to run it either as a variable specific heat or constant specific heat. If you go back and look at the exam, practice exam, you're going to see lots of problems that you can work with, and I encourage you to practice those. Now, on the next lecture, which is tomorrow's lecture, which is going to talk about transient systems, I want to let you know that transient systems are not on the exam. There are some transient problems that might show up in one of those old exams, but note, transient systems are not on the exam. So all you'll have is steady state open systems and closed systems for you to study. Okay, so here's how it'll go. Today there'll be a lecture. We're going to cover some example problems. There's no homework assigned today because it would be due on Monday, and I don't want you to worry about that for the exam. But I want you to work on these. This is kind of like me doing homework today together with me in this lecture. Tomorrow's lecture will be about transient systems. There will be homework assigned there. It will be due after the exam. Okay? Friday, there's no class, but I'll be posting a review lecture for you. That review lecture will be not required to watch, but it'll be something that you can watch over the weekend and coming into Monday. Monday, there will not be any new lecture posted because that lecture was basically the Friday lecture that I've given to you, the review lecture, and we'll get together Friday evening for an exam. Okay. In other announcements, I want to let you know that it's very important on your homework now to keep your diagram and to make sure that your assumptions are listed. I've been counting off a lot of points for people for not putting out a diagram. I've been counting off points for people not putting assumptions. There needs to be a defined assumption/model section. If you're rewriting the problem statement and the problem statement tells you something that's an assumption or model, you need to rewrite it in the assumptions model section. I know you may think that that's ridiculous, but I think that sometimes we get into cruise control with the rewriting the problem statement, and we don't take into consideration what that really means. So I want you to rewrite it as the assumptions and model. The picture, some of your guys' pictures have been very, very simple, and that's fine. I want a picture or a diagram, TV diagram, look at a box, a turbine, a compressor, anything like that. That's what I want you to draw, just something on that. We're dropping a lot of points because of that. Other thing is on lecture quizzes. If you see on lecture quizzes that you think that you were counted off unfairly because of something that I have programmed into the quiz answer, please make me aware of that so I can change that. There was a quiz that was for the continuity lecture, where the answer to the problem was that it should have been transient, and I selected it to be steady state, so I had to go back and edit that. And I think that the Canvas quiz did it kind of wonky, and it looks like that some of you got counted off for a correct answer. But just so you know, that last example problem should have been transient, and so I had to change that after the fact. But it may look wrong. It may look like I gave you 0 points for a correct answer, when in actuality you got 0 points because your answer is incorrect, and that you selected steady state when the answer was actually transient. So please let me know. Look over these things. Look over the comments that I posted on things. Please keep in touch with what I'm doing, and ask me questions if you feel like there needs to be things brought up to me that can help me or help understand where we need to go. Okay, those are the announcements for today. We'll get going with some open system examples here in our next video segment.